Ain't no sunshine when she's gone. It's not warm when she's away. Ain't no sunshine when she's gone, and she's always gone too long. Anytime she goes away, wonder this time where she's gone. Wonder if she's gone to stay. Ain't no sunshine when she's gone, and this house just ain't no home. Anytime she goes away. And I know, 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 I know. Hey, I ought to leave the young thing alone, but ain't no sunshine when she's gone. Ain't no sunshine when she's gone. Only darkness every day. Ain't no sunshine when she's gone. And this house just ain't no home. Anytime she goes away. Anytime she goes away. Anytime she goes away. Anytime she goes away.
One, two, 1, 2, 3. Boogum now, baby, you don't catch me still on. I say boogum now, baby, you don't catch me still on. You got me doing funny things like a clown. Just look at me. When you wear your high boots with your hip hugger suit, it's alright. You're out of sight. And you wear that cute mini skirt with your brother's sloppy shirt. I admit it, girl, that I can't dig it. You know, I said, boogum now, baby, you're casting your spell on me. I say, boogum now, baby, you're casting your spell on me. You got me doing funny things like a clown. Just look at me. When you wear your bell bottom pants, I just stand there in a trance. I can't move. You're in the groove. Would you believe, little girl, that I'm crazy about you? Not gone now with your bad self. Ooh. My baby's casting spells on me. Ooh, now mercy, mercy on me. All right, when you wear those big earrings, long hair and things, you got style, girl, that show is wild. You wear that cute trench coat and you're standing and posing. You got soul, you got too much soul. I just said to not casting your spell on me. But I said not casting your spell on me. I said not casting your spell on me. Woo! I said not casting your spell on me.
Please be seated. Good evening and welcome to the graduation ceremony for the Department of Physics and the Engineering Physics major. My name is Irfan Siddiqui, Chair of Berkeley's Department of Physics. Before we begin, I kindly ask everyone to please silence your cell phones so we may fully enjoy and focus on this special celebration. It is an honor and a privilege to serve as the chair of this department. From this podium, I hope that I can adequately convey the commitment to education, the commitment to excellence, and the passion to excel in all dimensions of that term that is shared by our faculty, our staff, and our students. Berkeley Physics shines and has always done so because it is a reflection of the strength and perseverance of the people that hold it dear. This evening, you see our faculty in regalia of different colors, representing the various educational institutions that we have attended. However, we share one universal fact in common, and that is we are here at this institution because you, the students, are extraordinary. At Berkeley, we remain committed to protecting the values of mutual respect, inclusion, and academic integrity. This evening, we join together as a diverse community, honoring the remarkable achievements of our graduates. The physics department recognizes that UC Berkeley sits on the territory of Huichin, the ancestral land of the Chochenyo-speaking Ohlone people. This land was and continues to be of great importance to the Muwekma Ohlone tribe and other familial descendants of the Verona Band. I am delighted to welcome to this Berkeley graduation ceremony the parents, families, and friends of our students who made this all possible. Students, would you kindly stand and face the audience at this time? And look up. Graduates, please join me in applauding your families and friends in recognition of the love and support they have provided during your years here at Berkeley. Thank you. Please be seated. Dear guests, we, the Berkeley faculty and staff who have worked with these students, are very proud of their accomplishments. We have watched a talented group of young people progress through a challenging curriculum, emerging as confident young innovators with promising futures ahead. And now I'd like to introduce the people joining me on stage. Please hold your applause until the introductions have been completed. We have Professor Stephen Kahn, Dean of Mathematical and Physical Sciences in the College of Letters and Science and Professor in the Departments of Physics and Astronomy. Professor Saul Perlmutter, today's principal speaker, Franklin W. and Karen Weber Dabby Professor, 2011 Nobel Laureate in Physics. Professor Yuri Kolomensky, Vice Chair for Instruction in Physics. Professor Holger Mueller, Head GSI Advisor for Physics. Professor Jeffrey Neaton, Undergraduate Faculty Advisor for Physics. And Nadia Sun and Joseph Slivka, graduating students from the Physics Department, who will be our undergraduate and graduate student speakers this evening. I especially want to acknowledge the members of our physics staff who organized today's event. Claudia Trujillo, Nitin Srivastava, Elizabeth Nakahama Ryan, Kathleen Cooney, Marjani Jones, Ariana Castro, Sheila Javeri, Lisa Partida, Kate Burge, Sarah Whitmer, Roberto Barueto Cabello, and Roya Ferrazares. Thank you. Thank you for your exceptional work in bringing this ceremony to life. Families, this dedicated team, along with our instructional support staff and facilities managers, has not only made today possible, but has also supported and encouraged your graduates throughout their journey here. Their work, often behind the scenes, is essential to everything we do. Please join me once more in giving a heartfelt thanks to all our faculty and staff. Their commitment, guidance, and care have played a vital role in the achievements we celebrate today. Our graduating students are part of an extraordinary legacy here at Cal. The physical sciences have been an integral part of the campus from the beginning of the University of California 158 years ago. Berkeley, established in 1868 at UC's first campus, continues to be the world's most distinguished public university. Guided by the motto, Fiat Lux, the university's purpose is to create knowledge that will both inspire us and improve our lives, to be a beacon of opportunity for each new generation. This mission is dynamic and not static by any means. Physics is a discipline that has seen numerous technological revolutions, fueled by paradigm shifts in our basic understanding of the inner workings of the universe. unprecedented control of materials down to the size of single atoms, and new ideas of how to store and process information. In our age, we see the emergence of complexity in science as a common frontier as it's being tackled in a wide range of disciplines, including biology, data science, cosmology, artificial intelligence, and of course, quantum information. The physicist sits at the nexus of these contemporary fields and is thus well positioned to apply the foundational skills learned at Berkeley into a variety of real-world settings. Notably, while we are immersed in a rapidly changing world, one of the core principles in our field has remained constant. It is also good life advice. Ask the hard questions and be ready for the hard answers. In the past few years, the physics department has lost some very distinguished faculty and friends, and I'd like to remember those beloved colleagues today for both their remarkable contributions to science as well as the department. Their commitment to education continues to illuminate us, and part of their legacy are generous donations to help shape the future of this department. In 1981, Professor Mary Kay Gaillard became the physics department's first tenured female faculty member. Her career as a theoretical physicist spanned the period from the inception in the late 1960s and early 70s of what is known now as the Standard Model of Particle Physics, and its experimental confirmation, culminating with the discovery of the Higgs particle in 2012. Upon Mary Kay's passing 1 year ago, we learned that she and Bruno Zumino had left the Lineweber Institute for Theoretical Physics, a remarkable endowment that shall be used to support graduate students and postdocs. During their lifetimes, Mary Kay and Bruno had created the Benjamin Lee and Julius Weber Graduate Fellowship in honor of their greatest collaborators. Professor Korkut Bardakcha joined the physics department in 1966. He made seminal contributions to quantum chromodynamics and string theory, including a new type of mathematical structure within string theory, the affine-Lie algebra, which enjoyed far-reaching applications. Korkut left a sizable endowment for the Lineweber Institute for Theoretical Physics to support graduate students and postdoctoral fellows who will continue to advance the fundamental questions about matter, space-time, and the universe. Last fall, Doug Giancoli, whom many of us had met in the hallways and stopped to chat with, passed away after a bout of pneumonia in his beloved Italy. Doug received his BA in physics summa cum laude from UC Berkeley in 1960, his MS in physics from MIT in 1961, and his PhD in elementary particle physics from UC Berkeley in 1966. Doug taught a variety of undergraduate courses, and he worked steadfastly to improve his physics textbooks, which have been used in our classrooms for many years, seeking ways to provide a better understanding of physics for students. Beyond Doug's intellectual contributions, he was also a generous benefactor to our department. In fact, I am the holder of the Douglas Giancoli Chair, which he funded. We are deeply grateful to him for his donations to support our upper division labs and our ability to recruit excellent faculty. Professor Howard Shugart passed away in 2016, and his wife Betty left us just last year. Howard received his BS in physics in 1953 from Caltech and his PhD from Berkeley in 1957. He was a dedicated teacher, and in 1988, he became the second recipient of the Donald Sterling Noyes Prize for Excellence in Undergraduate Teaching. In 1993, he received the Berkeley Citation for his dedication to the department and the university, and for his impeccable integrity, courtesy, and modesty, which is universally recognized and respected. Years ago, Howard and Betty created the Shugart Fund, which was recently converted to the Shugart Chair. The current chairholder is Vice Chair Professor Dan McKinsey. And finally, Professor Herb Steiner, who spent 77 years at Berkeley. In 1947, Herb came to Berkeley as an undergraduate, and he began his graduate studies in 1951. Under the guidance of Professor Emilio Segre, Herb studied fission of heavy elements and high energy collisions for his PhD dissertation. As a graduate student, he was recognized for his important contributions to the Chamberlain-Segre experiment at the Bevatron that discovered the antiproton in 1955, ending the debate of whether or not it exists. Herb and his wife Emily have also created a legacy in the physics department. They have funded both an endowment to support graduate students. And I'm very excited to share with you in this very public venue that they have funded, and Herb, ex-department chair, saw fit to leave us with a major gift, an unprecedented gift to revamp our entire undergraduate curriculum. It is incredible to see the growth in the number of students matriculating at Berkeley and the remarkable sustained increase in the number of physics majors that complete the program. It is time to reboot and rethink how best to teach our remarkable students, using the tools of AI to generate custom-tailored learning programs, re-envisioning how best to use the time of our graduate student instructors, and critically, to think about what is it that we wish to teach our students and how should we gauge progress in that in a performance-based metric. We look forward to this endeavor, endowed by the gifts of faculty that have left us so recently. In their lives and in their legacies, all of these great scientists, Mary Kay Gaillard and Bruno Zamino, Karkat Badakcha, Doug Giancoli, Howard Shugart, and Herb Steiner, saw fit to support the future of physics by paving the way for young scientists. I hope you share in the gratitude I feel as department chair for these giants whose shoulders we stand upon. Students, you are now part of Berkeley history. Thank you for being a part of Berkeley's journey. We are honored to have you as Berkeley alumni. Yes, we have been your teachers, your guides, but you walked the path, mastering the most difficult courses, becoming physicists. Dear guests, about 1/2 of our graduates are headed for graduate school, while others are headed for careers in education, industry, medicine, and engineering. Our students have the foundations they need to do whatever they deem most important and most interesting. They have become confident problem solvers, deftly able to deal with the increasingly complex world we live in, whether it be in driving the third quantum revolution, using physics to unlock the complexities of the human brain, or in bringing forth solutions to preserve this planet for generations to follow. Dear students, in closing, dear graduates, on this day you have indeed earned the right to revel in the glory of a great achievement. As physicists, you have earned a license to think, and this skill is invaluable and timeless. I have faith in your abilities to continue the Berkeley tradition, to not only have excellence in one's discipline, but to pair that with a strong commitment to civic duty. The training wheels are now off, and we need you to keep the train on the tracks. We need your problem-solving skills, your compassion, your wisdom to make sure the community principles you helped develop during your time here, values that are dear to Berkeley physics, illuminate the individual paths that you will follow. This is a beginning and not an end. In the words of the Stoic philosopher and the last emperor of the period that is referred to as the Pax Romana, Marcus Aurelius, I wish to share this very brief statement from Marcus Aurelius. If it is not right, don't do it. If it is not true, don't say it. As our newest alumni, you are the university's best ambassadors. You are a testament to the power and value of education. Your future achievements will demonstrate to our state what a treasure it has in the University of California and its crown jewel, Berkeley. Please stay in touch. Join us on social media. Return for our special lectures and volunteer to talk to students. This great university relies on the success and support of our alumni, which now include you. Fiat Lux. And now I'm delighted to introduce our physics undergraduate student speaker, Nadia Sun. Nadia Sun is a physics major with a minor in mathematics. She conducted research in atomic, molecular, and optical physics in a precision measurement experiment. She also greatly enjoyed serving as a tutor, a teaching assistant, and an officer for the Society of Physics Students. She will pursue a PhD in physics with a focus in quantum sensing and measurement. Nadia.
Thank you, Professor Siddiqui. Oh, yep. Okay. Sorry. Good evening, distinguished guests, faculty, family, friends, and fellow graduates. Thank you for inviting me to speak here today. It is my greatest honor to address you all this evening, and even greater honor to have the pleasure of learning and growing with you here at Berkeley. It is truly amazing to see how much has changed ever since many of us has first stepped into the physics building. I remember the first thing that stood out to me about the department was how rich the collaborative spirit was and the willingness to just dive in and try. I grew up in Singapore, where getting the highest possible exam score was the #1 priority. I was taught that learning was linear, and as long as I was following the correct path, I would find success. It was like trying to beat a set sequence of levels of a video game, where every challenge was clearly defined and the road forward was rigidly paved. I wasn't even allowed to take biology and physics at the same time. So you could imagine my surprise when I came here and found out that my first class was taught by a professor who studied biophysics. I think I truly realized things were different here during one of my first office hours. I walked in expecting to quietly wait my turn to ask for help, but instead realized that people were talking all together, comparing ideas, probing beyond the problem, openly admitting that they were confused. And none of us really knew each other. Somehow, we ended up working through the homework together. And that was how my first study group was formed. Not because we knew the right answers, but because we were willing to try to figure it out together. It was through this community that allowed me to break out of the cookie cutter mindset that I had been in. When I first started, I kept beating myself up trying to optimize every aspect of my life. I fixated on the right classes to take, the best opportunities to pursue, the one correct approach to solve every problem. I think many of us came to Berkeley with some version of this mindset. We are surrounded by many exceptionally driven and intelligent people. So it is very easy to feel like every decision has to be perfect, or that you need to have all the right answers. But through my interactions with all of you, I gradually realized that there really isn't just one way to approach things, not in physics and certainly not in life. From working through a derivation to figuring out what to do after college, the singular best path doesn't exist. And more importantly, it doesn't have to. If there's one thing that Berkeley has taught me, it is this: it is okay not to know. It is okay to try something without knowing it is going to be the right choice, because the only way to figure it out is to simply try. I think many of us felt like we needed things to feel certain before taking a step forward. But being here, surrounded by all of you who share your ideas freely, who aren't afraid to make mistakes or admit them, and who are willing to just dive in, has at least made me trust myself a little more, to be kinder to myself, to stop treating every decision like the be-all or end-all. And I'm so incredibly grateful for this community that made that possible. We have all made it through one of the most challenging academic programs in the world. And if we can get through this, we can get through what is next. Some of us may not know what we want to do exactly. For some of us, that path might change or might not be clear at all. And that is okay. We have time, and we have each other. We might not be struggling over problem sets together again, but we are stepping into the much bigger battle of life, full of uncertainty, with no ideal conditions like the absence of air resistance or perfectly spherical cows. But as we move forward, I hope that we can continue to carry with us the same spirit that brought us here, the willingness to try, to explore, to fail, to learn from each other, and to embrace the unknown. So don't worry about having all the answers. The future is something we can shape as we go. We are more ready than we know. Thank you so much, and all the best.
Thank you, Nadia. and best of luck to you. I am delighted to now introduce our physics graduate student speaker, Joseph Slivka. Joseph Slivka is a sixth-year graduate student in Professor Ahmed Yildiz's biophysics group, where he works at the intersection of physics and biology to observe and model the mechanism and regulation of biomolecular motors that shuttle organelles inside neurons. Joseph grew up in Manistee, Michigan, and did his undergraduate at Michigan State University. In addition to research at Cal, he has assisted instructing for 2 upper division physics courses, has taken part in the COMPASS Project initiative to increase undergraduate retention in the physical sciences, and has served as a Physics Innovators Initiative Pi-Squared program mentor and liaison. In his free time, Joseph plays any sports he can get on campus and gets together with his physics cohort for games, virtual or tabletop. Joseph.
Hello, everyone, and thank you for the honor of being able to speak in front of you all today. I wanted to take the opportunity to offer everyone my congratulations. Congratulations, class of 2026, we did it. Whether working late into the night on research or lab projects, whether it is meticulously crafting a final report or a publication, whether it is reciting and repeating a talk for a presentation among peers or that of a national level conference, and whether you were the active proponent of these endeavors or for the friends, family, and mentors in the audience, a supporter of your recent graduate, everyone in this room has been forged by trials and tribulations and committed to crafting a unique, fulfilling experience here at Berkeley. But as I stand here today, it is hard for me to offer such petty congratulations. What praise can possibly encapsulate the contribution to physics the people in this room have been instrumental in making? What words of encouragement can I give to a room of such driven individuals? What words of wisdom can I bring to some of the most intelligent people that I've ever had the pleasure to meet? So I decided to offer this. Don't let that unique experience, the one you work so tirelessly to craft, be isolated, alone, and wasted. The last 6 years have shown me just how transformative we can be when we share our perspectives and our passions. I have seen spectacular commitment to teaching. When I started grad school, we were in the midst of a global pandemic, but professors and staff like Professors Hossepfel, Luke, Wynne Williams, and the late Joel Fajans worked full-time to bring the Electronics 111A lab to students isolated in their homes, and graduate students and instructors did lab checkoffs over Zoom. And transfer students, Katie and Sean, made tutorials, shared their knowledge to improve the course experience for the next semester of students, bringing their experience to them. When I was able to GSI for my advisor, Professor Ahmed Yildiz, 4 years later, he showed me the true teaching dedication in Introduction to Biophysics. I will never forget his commitment to providing a spectacular learning environment for the students, nor my interactions with my amazing class, some of whom I am proud to say are in the audience today. I have seen everyone use their experience to contribute to the department through dedicated grassroots efforts. Graduate students, Andres, Jackie, began the physics-directed reading program, probably some that you've gone through, to help bridge the gap between grads and undergrads by leading reading groups, which has contributed and lasted for the last 6 years, with support from mentors like Kyle, like Bethany, like Malcolm, and Emil. Many of you have contributed time to a plethora of research programs to make research accessible to trainees, some of which are the Physics Innovators Initiative. I know Nicole, Johannes, Ko, Ruishi, and Jacob were some of those people. Remote experience for young engineers and scientists, Yvonne and Professor Raul Briseño, my apologies. Network for neutrino astrophysics and symmetries and summer undergraduate research fellowships, just to name a few. And I am inspired every day by the outstanding commitment from the department directors and the administrators who continue to support groups like the Society of Physics Students, keeping the undergrad community together, like the Women's Society for Women in Physics, bridging together those from all academic walks of life, like the COMPASS Project, where leaders like Donnie carried a no jargon lecture series for countless years, and iGen Spectrum, continuously advocating for departmental changes to include everyone, no matter gender or sexual orientation. I am truly honored to be among a part of this amazing community, one that truly values providing your time and your effort to bettering the world. And it is now more important than ever to maintain that community and that connection. We have remained vigilant, coming together in difficult and tumultuous times. The grad and postdoc population unified in a strike, collectively bargaining to achieve a more stable future for the training stages of the research hierarchy. Thanks, Burhan. Among unprecedented cuts to research funding and the bright future of science dimming, we persevere in the face of great uncertainty. We must continue to remain united, use our skills, our tools to understand and apply the essence of the universe, one of the most fundamental endeavors that make us human. Each of us is but a single individual element. We are not omniscient. We are not infallible, but we are merely physicists. And only by putting all of us together, we create something greater than the sum of any of its parts. So we are now the class of 2026. We are in a new year with many unsolved issues and unknown frontiers to push. But unresolved problems require not caving in the face of danger, not just relying on current technologies, not just staying in your comfort zone, because that is easy. We strive to challenge, push the frontier of what we and the world know. A cacophony of headlines and social media scream that you don't owe anybody anything, because that is easy. But we must choose the more demanding path, support each other even when it seems inconvenient, and offer the world what you can. I have already cited countless examples just tonight. And misused technologies like AI may reduce, fragment, and erode the human experience because that is easy. We must do the harder thing, seek out community, learn to truly learn, stay grounded in our path, engage in difficult conversations, be willing to be wrong, and adapt in an ever-changing world. Because if there's one thing I know about this room, it is that we are Berkeley physicists. We don't care if it's easy. We care if it can and should be done. So make it happen. Thank you, and congratulations to the class of 2026.
Thank you, Joseph. And indeed, the best of luck to you as well. I'm delighted to introduce today's commencement speaker now, Dr. Saul Perlmutter. Saul Perlmutter is a 2011 Nobel laureate sharing a prize in physics for the discovery of the accelerating expansion of the universe. A professor of physics at the University of California, Berkeley, and a senior scientist at Lawrence Berkeley National Laboratory, he is the leader of the International Supernova Cosmology Project, co-director of the Berkeley Center for Cosmological Physics, and the founding director of the Berkeley Institute for Data Science. His interest in teaching scientific-style critical thinking for scientists and non-scientists alike led to the interdisciplinary undergraduate courses Physics and Music, and Sense and Sensibility and Science, that he has now taught for over a decade. The latter of these inspired the publication of Third Millennium Thinking, Creating Sense in a World of Nonsense, a book that brings the course concepts to general audiences. An author of hundreds of scholarly articles on cosmology, Professor Perlmutter has also written popular articles and has appeared in PBS, Discovery Channel, and BBC documentaries. He is a member of the National Academy of Sciences and the American Academy of Arts and Sciences, as well as fellow of the American Physical Society and the American Association for the Advancement of Science, amongst other awards and honorary degrees. His AB was from Harvard and his PhD from UC Berkeley. As part of his public service work, Professor Perlmutter was a member of the U.S. President's Council on Advisors in Science and Technology, the PCAST, for the Biden administration. Please welcome me, and please join me in welcoming Saul Perlmutter.
Well, good evening and congratulations to the class of 2026 and to your parents and families and friends who are here. All right, it's clearly odd to be standing up in front of you wearing this regalia, but I think the whole idea is that we're supposed to be trying to create a really unusual, heightened moment that we'll all remember for years to come. And of course, that's great, but that means I probably am supposed to tell you something that I hope you will remember for years to come. Now, I'm going to try and I'm going to follow on my colleagues here who I think have started off well in this direction. And I want to do this in the form of a really big challenge for the group here. And ideally, it's an optimistic big challenge, but you'll see what I have in mind. Before I do that, though, I want to explain why I think this group, you physics graduates with fresh degrees from the University of California, Berkeley, are the right group to take on this challenge. Let me begin by asking everybody here in the class who's graduating to pause for just a moment and think about one example of a really, really difficult problem set that you faced in one of your classes. And ideally, it's a case where when you first saw the set of problems, you just had no idea how to solve it. You spent some time on it, and you still had no idea how to solve it. Then after a few days, you still couldn't solve it. And then finally, after a week or so of work, you were able to figure it all out. And now for the family members here, I should comment that this has happened to almost every one of us in the physical sciences, and we've all had this experience. I certainly remember that feeling very well of facing a problem set and just feeling lost. So next, for the class, what I want you to remember is when you solve that problem set, who you were working with. Because one of the real experiences of working in these fields is that you find that you work with other people and eventually solve seemingly completely impossible problems. And actually, since some of the people are probably here in the room with us, you should look around and see if you can catch each other's eyes, and you can wave to each other if you find each other. But the idea here is that there is something about doing problems and problem sets over and over for years, as you have been doing, that makes you begin to get comfortable with the idea that things that look impossible to solve can be solved if you understand what the problem is and if you work with other people. Now, finally, for those of you who had a chance to do some research with one of the faculty in the field, I know that there's a very large, and I know that that's a large fraction of you, you've probably had the experience now of seeing cutting-edge scientists have to take their work and let it be attacked by people who will likely disagree with them. In fact, it's one of the really striking aspects of how science works that we have to go in front of people at a conference, send our papers in for review, and people will give you a hard time. And I think it's a really valuable part of the process because it's built on the fact that we are very aware that we tend to get things wrong. We tend to make mistakes, and that it's really hard to see your own mistakes. It's even hard for people who agree with you to see your mistakes. So you have to go in front of people who will not necessarily agree with you. It's something that I think our society has clearly lost track of, but it's something that science has been built on. You can't fix your mistakes and solve the problems if you can't find them. Now, there are many other things I think you all have learned in your years here at Berkeley and that I could follow up with, but let's just go with those three to start with. And with those three in mind, let me present you with the challenge that I want to give you. And then this challenge comes about because, for this group, comes about because you happen to be born at a remarkably unique moment in human history, in the history of life, maybe even the cosmic history in the local set of galaxies. And that moment that you happen to be born into is the first time ever in which there are beings on this planet in a position to be able to solve really, really challenging world-scale problems that we never thought we could solve. So, for example, you happen to be born at a time when we know how to feed the planet. When I was a child, it wasn't clear that you could even feed 2 billion people. Today, it's pretty clear that you could feed 8 billion people and more. You happen to be born at a time when the next pandemic comes along, and there always will be another one, we have a reasonable chance of being able to deal with it. Previous pandemics could wipe out big chunks of the population. In our case, we think we have ways to tackle the problem. We're even living at a time in which, if the climate is changing, we have the tools to try to stabilize the planet's climate. Climates have changed dramatically over history and, in fact, wiped out civilizations. But you are born in the first generation where we actually seriously could think about what does it take to stabilize a climate. In fact, even if an asteroid or comet were coming in and threatening the Earth, we know things that we could do to avoid being hit. And of course, some of the last times that's happened, that's wiped out 90% of all families of species on Earth. Today, we have something we could do about it. The dinosaurs obviously didn't. So this is really an unusual moment. And I had always imagined that this would be a great moment of joy and engagement of the entire world, where we can now turn to each other and ask, okay, we can do all these things. What world would we like to live in? How would we like to construct a world where people are fed and clothed and housed and educated and have opportunities? What would that look like? What would make a world that we would all feel proud to live in? This would be an amazing moment to be thinking through that question with other people. Now, that's probably not what you are imagining when you get asked to envision the future right at the moment. And that's because the story that you hear is almost all of the fears and dangers and all the ways that things can go wrong, are going wrong, and have gone wrong. And I should say this very clearly, those are true too. It's not that the world can't be scary as well. It's just that if all we are is scared, then we don't actually take on the problem and try to solve it. At the moment, it seems like the biggest missing ingredient in everything I just told you is the ability for people, for humans, to just talk to each other in a constructive, useful way, to try together to take on problems. And even talk to people that they disagree with, crazy as that might sound, and figure out together how they're going to take on the problems. That apparent inability to think constructively together is currently the big unsolved problem. But as we've just discussed, we have learned once you identify a problem, you have a fighting chance to solve it. And we can't solve it if you don't have that sense of the scientific optimism that I'm describing, that allows you to stick with a problem that looks unsolvable, but knowing that you can work with other people, knowing you can work with people you disagree with, and knowing that together you can solve what looked like unsolvable problems. This group, then, is one of the few groups that can inject this can-do spirit into the world when you go out and start to make a life for yourselves. Now, I'm tempted to say, well, this is your job, it's your generation, don't worry about the older generation that's going to keep sending those scary messages in the news. But I don't want to abdicate all responsibility. I think we have to be doing this together with you, and I hope that everybody will join in on this. But you do have an unusual moment that you can remind the world that you're the generation that was born into this possibility for the world that I was imagining. So I hope that this can feel like an exciting time to be living in, and that it's full of potential. And I congratulate you on graduation, which allows you that sense that you can move into a world and start to help to shape it. We really look forward to what you will all be doing in the upcoming years. So again, congratulations and thank you.
Thank you, Saul, for your wonderful comments and for all the things that you do to enrich our department. I think all of us, we owe you another round of applause. We now turn to the awards in physics, starting with the Department Citation Award. The Physics Department citation is awarded to a graduating student in recognition of distinguished undergraduate work. With so many outstanding students, it was a tough decision. The 2026 Physics Citation Award goes to Nadia's son, who we just heard from our undergraduate speaker. Nadia is a physics major with a minor in mathematics. She will pursue a PhD in physics with a focus in quantum sensing and measurement. Please join me, Nadia, as I hand you your certificate. Next, it is my pleasure to announce the winners of 3 Graduate Student Research Awards: the Lars Cummins Award in Experimental Physics, the Jackson C. Koo Award in Condensed Matter Physics, and the Alex Zettel Graduate Student Award in Physics. Will the awardees please come to the stage? The Lars E. Cummins Award was created in honor of the son of Professor Eugene and Mrs. Ulla Cummins. This award pays tribute to the interests and accomplishment of Lars, who was a decorated engineer with a deep interest in experimental physics. It is given annually to the most outstanding graduate student in experimental physics, and I am delighted to present the 2026 Lars E. Cummins Award to Ashwin Singh. Ashwin, to add a few more details, is a graduate student in Holger Mueller's group. His research is on developing a novel experimental platform for trapping small chemically stable molecules at cryogenic temperatures. To achieve this, he has theoretically studied the dynamics of the trap, developed the world's most intense continuous laser, performed detailed studies of optomechanical phenomenon, and designed and built a unique cryostat buffer gas system, all with the hopes of answering fundamental questions about quantum mechanics of cold molecules. That was Ashwin. And now, moving on to the Jackson C. Koo Award in Condensed Matter Physics. Next, it is my pleasure to announce the winner of this award. The Jackson C. Koo Award was created in 2009 to recognize outstanding advanced graduate students in condensed matter physics. Jackson Koo received his bachelor's and master's degree with honors in electrical engineering, followed by a PhD in physics in 1969 under the guidance of Professor Erwin Hahn, all from UC Berkeley. He was a member of Phi Beta Kappa and of the Honor Student Society of UC Berkeley. After graduating, he worked at Bell Laboratories and then at Livermore National Laboratory. This year's Jackson C. Koo Award in Condensed Matter Physics is presented to Yuishi Chi. Rishi, to add more detail, is a PhD student in physics at UC Berkeley, working with Professor Fang Wang. His research focuses on strongly interacting electron-hole systems in two-dimensional van der Waals heterostructures, including excitonic insulators and condensates. After graduation, he will join Stanford University. Oh, we may have to take this award back. He will join Stanford University as a Stanford Science Fellow. Okay, you can keep it. Congratulations, Rishi. And don't go too far just yet. So the third graduate student award, the Alex Zettel Graduate Student Award in Physics. The Alex Zettel Graduate Student Award in Physics was established in 2022 with a gift from Erica and Herbert Zettel to be awarded to a graduate student in the Department of Physics with the most influential research accomplishments. Professor Alex Zettel received his BA from UC Berkeley in 1978 and his PhD from UCLA in 1983. He has served as a faculty member of the physics department at UC Berkeley since 1983, where he became a leading expert in the synthesis, characterization, and application of low-dimensional materials. Currently, he is a professor emeritus of physics at UC Berkeley, senior scientist at LBNL, and member of the Kavli Energy Nanosciences Institute at Berkeley. This year's Alex Zettel Graduate Student Award in Physics is presented to Rishi Chi once more. And your science has not changed from the previous award. So moving on now to the Student Service Award. The next award, the Physics Student Service Award, is given to recognize the importance of contributions made by students to the physics community. We encourage students to work hard for themselves in coursework and research, but we also value the importance of seeing beyond personal gain to the greater good of our community. These awards are difficult to give because so many students donate time and energy to a variety of important activities. This year, we are recognizing one undergraduate student and one graduate student for outstanding service to the physics community. The awards go to Abby Schley and Andres Antonio Franco Valiente. Abby, please come to the stage. For Abby, studying physics has always been connected to a larger commitment to community, inclusion, and accessibility. Her work has included serving as Equity Inclusion Chair for the Society of Physics Students, Undergraduate Diversity Coordinator for the Voice Committee, Physics Peer Advisor, Mentor to Undergraduate Research at Undergraduate Laboratories, and Facilitator for the DECAL seminar, Hidden Intersections. Alongside this work, she has pursued research in black hole lensing, cosmology, and extragalactic astronomy. She plans to carry both her scientific interests and her commitment to supporting others into graduate school and ultimately into a career in academia. Congratulations, Abby. Andres, please come forward to the stage. Andres has made an extraordinary impact on UC Berkeley physics community through his leadership, mentoring, and unwavering commitment to transfer student success. A transfer student himself as an undergraduate at Berkeley, Andres transformed his own experience into a source of support and inspiration for others navigating the transition into Berkeley's rigorous physics curriculum. As the primary graduate student instructor for Physics 153, the foundational course for physical science transfer students, he became an essential mentor and advocate, creating an inclusive, welcoming environment where students felt not only academically supported, but genuinely seen and valued. Known throughout the department for his compassion, initiative, and collaborative spirit, Andres has been a driving force in fostering a more inclusive and supporting physics community for all students. Congratulations, Andres. Okay, we would like now to honor the outstanding graduate student instructors with our OGSI awards in physics, selected by undergraduates and faculty for their excellent teaching. This year's recipients are Ji Chao Feng, Chad Harper, Denali Alexander Jha, Alex Liebman Palais, Bianca Julia Paul, Shreya Venkatanaga Puranam, Harry Chian, Dylan Joseph Raphael, Valeria Rosa Arocha, Roshni Singh, Samara Steinfeld, Spencer Tamagni, Siddharth Tiwari, Jianji Zhu, and Auden Young. These graduate student instructors have made extraordinary contributions to undergraduate education through their teaching, their motivation, and enthusiasm. Congratulations and thank you. Please join me in a round of applause for these instructors. It is time, Dean Khan, to do the main thing. And as you notice, as a quantum physicist, there's no way I can tunnel through this gap. Okay. So we are now ready for the conferral of degrees. As a courtesy to the graduates, all guests, and for safety reasons, please remain in your seats at all times and do not approach the stage. We have a professional photographer here today, Grad Images Photography, who will be mailing proofs to graduates directly. Dean Khan will now confer the bachelor's degrees for physics on behalf of Chancellor Richard Lyons after making some remarks. Dean Khan.
Thank you. Thank you, Irfan. And wow, what an exciting evening this is. Although I've been doing this for several years now, I always find it deeply moving to see such a wonderful array of students. Let me also add my formal welcome to the family and friends who are here to help celebrate this great occasion. We have one of the best physics departments in the world, in my view, the best physics department in the world. But our students are our most prized resource. To our students, I know you have all been working hard towards this day for several years. And these, of course, have been somewhat difficult years. The achievement we are making here today is all the greater for the challenges that you and we have faced. I want to celebrate the strength, resilience, creativity, and tenacity that you, our wonderful students, have shown. These are qualities you will carry forward with you into your lives as you proceed onward with your careers. You have all emerged as amazing scientists. The best part of being on the faculty at Berkeley is engaging with you, our students. Nothing is more thrilling than sharing in that spark of a new idea that emerges during a class discussion. Whether or not you stay in the field of physics, I hope you'll always be curious about the profound questions we face as physicists. In the past year or so, we've seen our leaders attack the very foundations of science, what science is about, and the funding that provides it. As you move forward in life, I hope that you'll carry that curiosity that has enabled you to get through these years, and also to influence your friends and family to convince them that science is actually fundamental to our civilization. I also want to thank the faculty and staff in the Department of Physics. These have been challenging years for them also, and I never cease to be impressed by the dedication of our staff and faculty to delivering on the core mission of our campus, teaching, research, and service to our communities. So thank you to you also. And finally, a special word of thanks for our MC, our host, and Department Chair Irfan Siddiqui. Irfan has been chair over the past 3 years. He reluctantly took on the job when I asked him to do it, but he's performed amazingly in that role. And I think all of my faculty colleagues have been really happy with Irfan's leadership. It's been a pleasure to work with you. Okay, now on to the reason that we are all here. On behalf of the College of Letters and Science, I'm going to confer the degrees. First, the bachelor's degree in physics. The Bachelor of Arts degree is conferred by the College of Letters and Science at Berkeley after a program of study usually requiring 4 years, which includes both general studies, broadly distributed as to field, and specialized studies at greater depth within a major subject. The aims of the bachelor program are twofold. First, it is to equip the candidate with the benefits of a liberal education in preparation for whatever leadership in society he or she may be called upon to exercise, and to equip him or her for further intellectual growth. Second is to prepare the candidate for further work in the major subject or some related field, either by formal academic study as a graduate or by employment. Will the candidates for the degree of Bachelor of Arts please rise? By virtue of the authority delegated to me by the Regents of the University of California, I hereby confer upon you the degree of Bachelor of Arts and of Bachelor of Science and all rights and privileges pertaining to that degree. You have taken the first step afforded by traditional academic processes in the development of a scholar, and I welcome you to the ranks of educated men and women. The candidates will now approach the stage and receive their degrees.
Ari Katz. Carl Wilhelmsen Emdenby. Jakub Montin. Kashav Thairsker. Sanjana Goyal. Kaylani Adcock. Mackenzie Castle. Abby Schley. Haiyang Hari Chen. Nathaniel Perel Fontanilla. Brennan Coffey. Maydalia Okali. Brandy Stokes. Nick Iskander. Sean June. Jonathan Tordilla. Ethan Hall. Maya Basu. Suranil Ahuja. Cameron Brown. Rania Hassan. Pengu Chen. Andrew Vashklevsky. Mengcheng Ma. Bo Wei Yang. Finn Reichertz. Adita Bhargava. Rishabh Deve. Matthew Bordeaux de Fontenay. Robert Woodward Hartman. Nico Rowland. Karina Lee. Julian Vale. Kai Swandi. Jack Reddick. Ajen Kael Vanessa de la Cruz. Sanaz Mizbani. Neil Nitin Agarwal. Surya Talavarjula. Oscar Nogales. Chuzida Chen. Veda Arakatla. Adam Zabrajer. Xing Li Yu. Aditi Anand. Meghna Subramaniam. Amy Jintian Chiao. Jyotsna Ravi. Nadia Sun. Emma Yu. Kylie Abu Khalilul. Yanhee Zhang. Nuvya Gupta. Hannah Malloy. Jenny Chen. Thomas Liu. Kang Tae Sun. Raiki Omori. Taiwei An. Jason Lay. Gurnur Kaur Bahati. Jasleen Kar Sandhu. Yara Bawazir. Jasmine Sandhu. Mustafa Abu Zaria. Aliza Hamid. Rebecca Mendoza. Claire Chen. Anand Menon. James Hunsinger. Sean Dolan. Cole Dunn. Sanjit Shirol. Rainer Rexek. Josh Zhang. Ryan Huangbo. Jorge Diaz Chow. John Goker. Sage Hironaka Remulia. Alana Paloma Waterman. Aaron Manohar. Shorya Jain. Curtis Hu. Siddharth Sahu. Garv Argawal. Ryan W. Kiesling. Evan Williams. Mito Funatsu. Casey Lin. Luke Peters. Barbara Borshirts. Ro'a Alkawaya. Christopher Zhongchang Lee. Eric Kevin Gedeman. Winnie Wang. Lindsay Yi. Nikita Akshan. John Chiavara. Yihua Lee. Connor James Navin. Hayob Habterwariam. Andrew Isaac Alatorre. Joseph Schultz. Jaime Alvarez. Jesus Ramirez Jr. Brock Bass. Dominic Wynn. Cooper Schnurr. Isabella Erickson. Omar Arakchi. Julian Ducoro. Yes. Mark Moreno. Liam Joyce. Iori Adachi. Siddhant Ambakar. Tanvi Batra. Kirtana Rumpf. Jack Collard. Viola Zixin Zhao. Kevin Godgen. Kiran Shantaloop. Ishwari Mishra. Lael River Williams. Martinez Hakivilis. Ricardo Zamora. Alonso Sanchez. Francisco Javier Molina Bonitez. Ricardo Valle Navarrete. Matthew Tu. Eli Zandro Disler. Brianna Peck. Kai Jarofarov.
Dean Khan will now confer the Master of Arts degrees for physics. We have 2 Masters of Arts candidates today.
The degree of Master of Arts is awarded by the Graduate Division of the University of California after a program of study, usually requiring 1 or 2 years beyond the bachelor's degree. In the master's program, the emphasis is upon coursework at an advanced level, often in preparation for teaching of the major subject at a college level, but sometimes in preparation for employment that requires a deeper knowledge of the specialty. Will the candidates for the degree of Master of Arts please rise? By virtue of the authority delegated to me by the Regents of the University of California, I hereby confer upon you the degree of Master of Arts and all rights and privileges pertaining to that degree. You have taken the second step afforded by traditional academic processes in the development of a scholar, and I welcome you to the ranks of those qualified to teach in your specialty at an advanced level. The candidates should now rise and approach the stage where they will receive a scroll recognizing their participation in these ceremonies. Roya Ferrazares will announce the scholars who have earned the Master of Arts in Physics.
Dana Griffith.
Dean Khan will now confer the degree of Doctor of Philosophy for Physics.
Recipients wear the PhD hood of the University of California. The design of the hood dates from medieval times when academic affairs were closely related to the affairs of the church. The length of the hood and the blue velvet border signify the PhD and are common among universities. The blue and gold colors of the satin lining of the hood designate that the degree was conferred by the University of California. Research toward the PhD degree is highly individualized and carried out in close association with a faculty research advisor. To symbolize this close bond, research advisors will hood their students who have earned the degree. The degree of Doctor of Philosophy is awarded by the Graduate Division of the University of California after a rigorous program of study and research, usually requiring at least 4 years of study, sometimes more, beyond the bachelor's degree. In the program for the doctorate, the candidate must complete advanced coursework in the specialty, must pass one or more advanced examinations set by committees of the faculty, and must carry out extensive original research in the specialty in preparation for the writing and defense of a thesis. The doctoral program is highly individualistic and requires commitment to an extended effort of unpredictable outcome. The doctorate prepares those who attain it for a career in college or university teaching and research, or for carrying out independent research at a comparable level in other settings. Will the candidates for the degree of Doctor of Philosophy please rise? By virtue of the authority delegated to me by the Regents of the University of California, I confer upon you the degree of Doctor of Philosophy and all rights and privileges pertaining to that degree. You have taken the final formal step afforded by traditional academic processes in the development of a scholar, and I welcome you to the ranks of those qualified for university teaching and research or for comparable scholarly work in other settings. The candidates will approach the stage where they will receive a scroll recognizing their participation in the graduation ceremony and be hooded. Please be seated until you are directed to approach the stage. Hooding faculty should proceed to the seats behind the stage and kindly stay there until the conclusion of the ceremony. Our ushers will direct you.
Will the recipients of the degree of Doctor of Philosophy now line up? Roy Ferrazalis will call your name and we will go ahead with the hooding process.
Joseph Slivka. Thesis title, Nanoscale Fluorescent Tracking of Cytoskeletal Motor Mechanism and Regulation by MAPs. Advisor, Yamet Yildiz. Faculty hooding student, Ahmet Yildiz. Kotaro Yamakawa, thesis title, On the Road to Realizing Topology in Correlated Magnetic Materials. Advisor, James Analytis, faculty hooding student, Irfan Siddiqui. Jose Soria, thesis title, Lightly Ionizing Particle Search and Improving Accidental Handling for LZ. Advisor, Daniel McKinsey. Hooding student, Daniel McKinsey. Stephen Gant, thesis title, Predictive Methods for Calculating Excited State Properties in Complex Materials at Finite Temperatures. Advisor and hooding student, Jeffrey Neaton. Malcolm Lazaro, thesis title, Hadronic Interactions from QCD. Advisor and hooding student, Andre Walker Loud, with Raul Briseño. Raysher Chi, thesis title, Correlated Exciton Physics in van der Waals Electron Hole Bilayers. Advisor and hooding student, Feng Wang. Burhan Edmud, thesis title, Microscopy of Bioelectric Potentials Using Electrochromism. Advisor and hooding student, Holger Mueller. Elizabeth Donaway, thesis title, Awakening Sleeping Giants, an Information Theory of Learning in Large Language Models. Advisor Mike DeWeese, hooding student Irfan Siddiqui. Shawen Chang, thesis title, Ultra-Cold Bosons and Fermions in Triangular Optical Pseudolattices. Advisor and hooding student, Dan Stamperkern. Jacqueline Ho, thesis title, Collective Cavity QED in Mesoscopic Atom Arrays. Advisor and hooding student, Dan Stamperkern. Ashwin Singh, thesis title, A Buffer Gas-Loaded Deep Optical Trap for Molecules. Advisor and hooding student, Holger Mueller. Emil Abrievich, thesis title, Supersymmetric Adventures in Class S Theory. Advisor, Ori Ganor, Peter Horava, hooding student, Ori Ganor. Andres Franco Valiente, thesis title, The Tropical Geometry of Non-Equilibrium String Theory, advisors Oregonor and Peter Harava, Hooding student, Oregonor. Johannes Wagner, thesis title, Transforming Higgs to Charm Measurements at the ATLAS Experiment, advisor and Hooding student, Heather Gray. Linus Hyunsong Kim, thesis title, The Superconducting Grid States Qubit, advisor and Hooding student, Irfan Siddiqui. Kai Isaac Ellers, thesis title, Towards New Laboratory Tests of Classical and Quantum Gravity, advisors Birgitta Whaley and Yasunori Nomura, Hooding student, Birgitta Whaley and Yasunori Nomura. Jakob Robnik, thesis title, Probabilistic Exoplanet Search in the Kepler Data, advisor Urosh Seljak. Bethany Suter, thesis title, Dark Matter Supersymmetry and Chiral Gauge Theories, New Tools and Phenomenology, advisor and Hooding student, Hitoshi Murayama. Mark Maus, thesis title, Cosmological Analysis Methodology Using Large-Scale Structure Surveys and CMB Lensing, advisor Martin White, Hooding student, Irfan Siddiqui. Kyle Ritchie, thesis title, Entanglement and Complexity in Gravity and Holography, advisor and Hooding student, Yasunori Nomura. Noah Goss, thesis title, Beyond Qubits, Qubit Quantum Computing and Many Body Simulation in Superconducting Circuits, advisor and Hooding student, Irfan Siddiqui. Brian Marinelli, thesis title, High Connectivity in Quantum Superconducting Circuits, advisor and Hooding student, Irfan Siddiqui. Larry Chen, thesis title, Addressing Key Scaling Challenges in Fixed Frequency Transmon Architectures, advisor and Hooding student, Irfan Siddiqui. Ahmed Hajar, Thesis title, Efficient Microwave Photons Wave Mixing with Superconducting Quantum Circuits. Advisor and Hooding student, Irfan Siddiqui. Bing-Cheng Ching. Thesis title, Quantum Computing with Superconducting Kerr-Cat Qubits. Advisor and Hooding student, Irfan Siddiqui. Leon Liu. Thesis title, An Interacting Atom Array in Cavity QED. Advisor, Dan Stamperkern. Sujia Ke. Thesis title, Non-Empirical Ab Initio Calculations of Spectroscopic Properties of Complex Energy Materials. Advisor and Hooding student, Jeff Neaton. Jonathan Reicheneder. Thesis title, First Principles Studies of Emergent Magnetism in Layered Quantum Materials. Advisor and Hooding student, Jeff Neaton. Jonathan Doldy. Thesis title, A Multiplexed Strontium Optical Lattice Clock. Advisor and Hooding student, Shimon Kokowitz. Donez Horton-Bailey. Thesis title, Tunneling Two-Level Systems in Amorphous Oxide Films. Advisor and Hooding student, Francis Hellman. Irian DeAndrea. Thesis title, The Mixed Basis Digitization Approach, Hamiltonian Large NC and Other Tools for Simulating Gauge Theories on a Quantum Computer. Advisor and Hooding student, Christian Bauer. Wei Chang Tang. Thesis title, First Principles Study of Electronic, Magnetic, and Optical Properties of Low-Dimensional Materials. Advisor and Hooding student, Stephen Louie. Ivan Mauricio Burbano Aldana. Thesis title, Formal Developments for Nuclear Scattering Through Quantum Computers. Advisors and Hooding student, Raul Briceño and Christian Bauer. Nicholas Gravina, thesis title, Quantitative Predictions of Transcriptional Regulation from Binding Affinity to Sulfate. Advisor Hernan Garcia, Hooding student Ahmed Yildiz. Nicole Neto Godry Farias, thesis title, Instrument Development and Data Analysis for the Simons Array and Lightbird Cosmic Microwave Background Polarization Experiments, Detector Arrays, Readout Electronics, and Optics. Advisor and Hooding student, Adrian Lee.
We hope that all of you, baccalaureates, masters, and doctors of philosophy, will look back on your time here at Berkeley with pleasure and with pride. You are part of a great tradition, and we are extremely proud of your accomplishments. We are now at the end of our ceremony. Guests and families, please remain at your seats and allow the graduates and faculty to exit the auditorium first. Then please feel free to exit and reunite with your graduates outside. But before we begin leaving, with all the graduates, please rise and face your friends and families. I present to you the class of 2026, Fiat Lux. Go Bears!